What if I told you black holes might be time machines, that your atoms could become holograms on the edge of the most mysterious objects in the universe? And if you screamed, your voice would never escape, frozen in time forever. Black holes challenge everything we know about space, time, and reality. But what are they really? And what happens if you fall in? Let's start simple. Black holes aren't giant cosmic vacuum cleaners. They're regions of space where gravity is so strong it traps everything, even light. That boundary, the point of no return, is called the event horizon. Once something crosses it, it's gone. No turning back. But here's the twist. If you swapped the sun with a black hole of the same mass, Earth would still orbit just fine. We'd just freeze to death in darkness. The black is the event horizon. But the hole, that's what lies beyond, a place where physics breaks. Black holes start with stars, massive ones, 10, 20, even 100 times bigger than our sun. For millions of years, they fuse hydrogen into helium, pushing outward to balance gravity. But when they start fusing heavier elements like iron, energy stops being released. Gravity wins. The star collapses in seconds. Boom, a supernova. What's left behind? A neutron star, or if it's massive enough, a black hole. Fun fact, every atom of gold, silver, and uranium in your body was born in a dying star like this. You can't see a black hole directly, but you can see the chaos around it. In 2019, scientists captured the first real image of a black hole's shadow, surrounded by glowing plasma, light bent by gravity. This was the Event Horizon Telescope, a planet-sized camera. Einstein predicted this, but Stephen Hawking added something wild. Black holes don't last forever. Here's how it works. Empty space isn't really empty. It's buzzing with quantum fluctuations. Pairs of particles pop into existence, one positive, one negative, and then they annihilate each other. But near a black hole's event horizon, one particle falls in, the other escapes. From the outside, it looks like the black hole is slowly losing mass, leaking energy. That's Hawking radiation. It's slow at first, but as the black hole shrinks, it radiates faster. Until, boom. A final explosion, the most powerful thing in the universe, just fades away. So, what if you fell in? From the outside, people would see you freeze at the event horizon. You'd turn red, then slowly vanish. But from your point of view, you fall. And fall. And then, gravity pulls harder and harder. Your feet feel way more force than your head. Your body stretches into a single strand. Spaghettification. Real word. Real nightmare. Here's where things get trippy. Black holes warp time. The closer you are to the event horizon, the slower time passes for you compared to someone far away. Near a supermassive black hole like Gargantua from Interstellar, 1 hour equals 7 years on Earth. So, yeah. Black holes are time machines. They don't take you into the future. They slow down your present. Let's compare Hollywood to real physics. Interstellar's Gargantua? Surprisingly accurate. Thanks to physicist Kip Thorne, it was based on real equations. The time dilation? Real. Now take Star Trek. They use black holes like teleporters or plot devices. Cool visuals, but no physics. Real black holes don't open clean portals. They shred you, collapse you, and maybe store your info as quantum code. No red shirts are beaming back from that. Here's the big debate. If you throw something into a black hole, is it lost forever? Einstein's equations say yes, but quantum theory says no. Information must survive. Stephen Hawking thought it vanished, but Leonard Susskind and others fought back. Thus, the information paradox. If Hawking was right, the universe breaks. So maybe he wasn't? Here's a wild idea. Everything that falls into a black hole is recorded on its surface. Like a hard drive, this is the holographic principle, suggesting all the 3D stuff inside a black hole is stored as 2D information outside. That means, in a way, you never fully vanish. Even crazier, some scientists think our entire universe might be a hologram projected from a higher dimension. What if we're the shadow on someone else's event horizon? Could humans make a black hole? In 2008, when CERN fired up the Large Hadron Collider, some people thought it might create a microscopic black hole and destroy Earth. Spoiler, it didn't, and even if it did, tiny black holes would evaporate instantly. But some physicists do think micro black holes could exist, and they'd reveal new dimensions. Yes, really, tiny black holes could open doors to new realities. Now, here's a real mystery. Could black holes be dark matter? We don't know what dark matter is, but it makes up most of the matter in the universe. One theory? Primordial black holes. Tiny black holes formed right after the Big Bang. They'd be hard to detect, but they might explain everything. Do black holes interact with dark matter? We think so, but we're still searching for answers. Inside the event horizon is the singularity, a point with infinite density. Time and space twist to infinity. Physics breaks down. What happens there? Some say total annihilation, others suggest a wormhole, a bridge to another part of the universe, or maybe even a new one entirely. Einstein-Rosen bridges, a real theory, not quite Doctor Strange portals, but the idea is serious. And physicist Roger Penrose, he thinks our universe may have emerged from a black hole in a previous universe. Would you jump into a black hole, E, if it led to another universe? Let us know in the comments. Let's rewind. Massive stars collapse. Black holes are born. Gravity traps time and light. Time slows near the event horizon. You spaghettify as you fall. Hawking radiation makes them evaporate. Information may survive, stored as a hologram. Black holes might be dark matter or wormholes or even universe makers. And someday, they'll be the last thing left in the cosmos. Black holes don't just destroy. They challenge everything we know about time, space, even who we are. The universe is expanding. So is human curiosity. Subscribe if your brain's still intact. There's more where this came from. Stay curious. Stay orbiting.